Today, I'm going to be talking to you about the work we have been doing with Nibi, our new cluster, which just came on this summer, to integrate on demand with it. So let's get underway here. So basically, going back to Graham, we realized that sometimes it's easiest to perform your pre and post computations or tasks where your data is. So typical situation this occurs is when your data is huge and takes a long time to transfer. So you've done some simulation and you don't want to have to copy that data down to your computer to do your work, which might involve, running a program like R and using its GUI or MATLAB or some custom post-processing application or pair review. So in those situations, it's much easier if you can run those graphical applications on the cluster where your data already is. Or the other situation we frequently saw is the individual's desktop was old or underpowered or didn't have the software they needed. Typically, it might be a desktop that had been provided to them by the university. They might not have administrator rights to put the software they want on it. Or also people would like to work at home and at university, and then they had the software at both locations, or they didn't have access to the licenses. So anyways, long story short, sometimes it's just easier if you can do those pre and post computation steps on the supercomputers as well. So to that end, we created Gray VDI for Graham. It was basically an interactive desktop that you could access right a bot way. You download some software called Tiger VNC Viewer, and you could connect to it. There was no waiting; it logged you in right away. Your session lasted as long as you kept the window open, and it had hardware OpenGL, which was useful for some applications with where you're viewing some complex scenes, typically some heavy pair view lifting or engineering applications looking at their geometry. There were some issues though. One of the issues was it was only available on Graham. Other sites had a remote desktop you could access via the web browser under Jupyter Lab, it was called, and which Graham had as well, but there was issues on Graham with regards to the software stack being old, caused some issues with the Jupyter Lab. And more importantly, it wouldn't work on some sites due to firewall or inability to install software. So again, users that did not have administrator rights on their computer might not be able to install the Tiger VNC Viewer software. Some sites are pretty particular about their firewalls, so they would block VNC packets from coming out of their university, or they would break the connections after short periods of time. And then internally, it was a bit of an issue too, because it was a custom image. So we had to maintain it, which was a security issue and a time issue for staff. I believe it was hacked once due to having not been updated. So anyways, those were some of the issues we were thinking of when we were rolling out Nibi and wondering what we should do. So in the end, we decided to try on demand. Sharcnet had already rolled out on demand for their users, so we played with that a bit and thought it looked like a pretty good interface. And by we, I mostly mean me. So there's not a unified opinion in the Digital Research Alliance amongst the consortium as to what's the best way, but this is a way we've decided to investigate and hope that it will be useful for you. So it's a web system for accessing supercomputers. It was created by the Ohio Supercomputer Center, so OSC, back in 2013, based on some work they had done starting in 2007, I believe it was. And it's been supported by a few NSF grants since then. So it's under active development. The development is carried out on GitHub. It's a friendly and active community. Since we've rolled it out, I've submitted a few requests and comments and always had very good interaction and had no problem getting our changes upstream. So that's good. And looking at their GitHub repo, sometimes you see when you go look up a project, you'll see the last commit was a year ago, and you're like, right, I'm probably not going to be able to get support, and this is going to fall out. But this is a very active project, daily commits, people working, features being merged and stuff. So that all bodes well. And then they periodically have a security audited by Trusted CI, which is a partner of the NSF as well. So they take the security serious, which is something that we are obviously concerned about as well. So some of the things that have us excited about on-demand from our side, the admin side. So as I've always talked about, the active community, the framework that they have developed is extensible. So that's nice. We're impressed with the security model. So basically, when you connect to it, you interact with the web service that's actually running as you. So that's sort of sandboxes the web stuff to the user for the most part. And of course, it doesn't require a custom image. It works with our existing cluster, which was one of our concerns going back to Gray VDI. Some of the things that we think might be good from the user's side is it doesn't require any software beyond a browser. So that means it isn't blocked by any site's firewalls. We even had one site who blocks SSH, which makes it pretty hard to access the clusters. So this provides a workaround there. The clipboard works with the desktop, so you can cut and paste between them, which was one issue I always had with Jupyter Hub. Kind of found it frustrating, especially with problem tickets. You wanted to, cut and paste some stuff into your ticket, and you found out you couldn't. There was a workaround, right? You could just cut and paste it into a file and then copy that file to your computer and cut it out of there. But so it's nice to have a clipboard that works with your desktop. And it also provides file transfers and login shell access too, because it's really intended for a complete access to the supercomputer. I've just been focusing on the desktop graphical interface because we're looking at that to replace Gray VDI on Nibi, but it has these other things as well. So it's available right now if you go to ondemand.sharcnet.ca. So it's still a work in progress as we firm up our vision. So we're moving stuff around and tweaking settings and stuff, but it is working, and we respect users are using it. So if we have to do any disruptive things like actually restart the service, we do that after hours. So during the day, it should be available and working fine. So I'll just bring it up here. OnDemandSharcnet.ca. So it logs in through our standard web identity service. So it's just your Compute Canada username and password, which I've entered wrong. And you have to do your Duo two-factor authentication. Which brings you to the interface here. So the exact menu layout is subject to change. And indeed, if you have been using it recently, you'll notice I totally reorientated it really recently to what I had kind of come to feel was better. But we might change this here again yet. But currently we got it broken into files, compute, login, and then this one here, if I make this browser window, is called my interactive sessions. So files is for transferring your file stuff to and from the cluster. So that avoids the need for a separate SFTP client, which is nice. Compute is for running stuff on the compute nodes. So that's basically stuff that runs in a job context. Login is for stuff that runs on the login nodes. And then the My Interactive Sessions allows you to connect to stuff that has been running on the compute nodes that provide a connecting interface. So primarily that would be the VNC, but it is technically possible. I mean, this was part of on-demand service to connect to various web interfaces and stuff provided by jobs. Oh, and then My Interactive Sessions. Okay, yeah, I think I talked about that already. It allows you to connect to them. So you can disconnect and reconnect. So the files menu is pretty straightforward. currently, I've only got a link to your home directory in here. I mean, we could add the others, but mostly that's because, once you're in your home directory, if you want to get to your projects directory, and different people have more than one projects, you can just, cursor down to your projects and then go into there to view your files. If you want to, you can do this sort of regular stuff. You can pick a bunch of files, delete, copy, move. You want to upload a file. You can do that here easily enough. Example, say I want to upload this hello C file. And there it is. I can actually edit files. If you just click on the file by default, it'll just bring it up into sort of a raw viewer. But if you really want, you can edit it here as well in a little GUI and save it. You can pick your keyboard bindings and your kind of syntax highlighting. Most options you pick, it opens up a new window. So it'll take you can just close it to go back to the previous one. If you want to copy or move it, so say I want to put it in the Flare directory for whatever reason, I can pick copy there, and then I can pick where I want to go, and then press well, let's move it in here. So hello.c. And if you're like me and you actually prefer a terminal, you can just always click open terminal, which will open a terminal in whatever directory you are. So you can, of course, run your commands there, or even indeed your editor you prefer our sort of system. So here I can move it back using the terminal. There we go. And of course, it will be back under Dev Tyson. So that's the basic web interface. Yes, and you want to avoid navigating to directories with many entries. Typical examples are home, scratch, and project. So in particular, where this bites people, I just want to get you guys aware of the get yous. If you kind of bump your way up one directory at a time and you hit the home directory, we have thousands of users, so your system will pause for quite a while it goes through and gets all those names to display to you. So you're much better to just do the change directory and directly add a pass. So say if I wanted to jump to Scratch Tyson, I'd do that way instead of going into the Scratch directory, which will then retrieve the list of all our users, which will be OL. Or you can just, of course, directly access the Scratch and project ones, which is, I think, the only reason you would really proceed outside of your own directory. You can access them directly with the links under home. Yeah, so that's files. Now login, I mean, most of what I'm going to be discussing is the compute, but login is stuff that happens on the login nodes. So being a login node, that's like when you secure shell in normally to access your session, it's instantly, it runs indefinitely, or well, close to indefinitely. We got some, timeouts that'll kill it after a month or something like that, but effectively indefinitely. But the thing about login nodes is on each machine, we capture all the programs, all the tasks, all the sessions ran by each user and stick them inside a C group. So that's basically a container, and that limits your total memory usage per login node across all your sessions. So whatever they are, they can't sum to more than 16 gigabytes, and the total CPU usage is tied down to 6 cores. And the reason that is because the login nodes, of course, have lots of people using them. So we don't want one user to use a tremendous amount of resources and interfere with everybody else's use of the login nodes. So currently the only login node option we have is to start a shell access. We might be going to add some additional ones there as well, which you've already seen the shell, but basically this replaces or allows you to do the same thing as you used to have to SSH. So at our institutions that have blocked the secure shell, you can use this as long as you got web access. You can use this to access your clusters. It just uses the credentials I used to log in to the web interface. And then when you close it, it's gone. It's like exiting your shell. It's done. There isn't really any timeouts. But as we said, this is the limits here, 16 gigabytes and 6. So compute is stuff that happens on compute nodes. If it happens on a compute node, that means it's happening in the context of a job. And it'll have whatever resources have been allocated to that job. It'll have however much time has been allocated to that job. So if we pull down the compute window here, we have a few options. So the primary one that I'm going to be talking about, of course, which was what got us to set up on demand, was the desktop, which is what we're looking to replace Gray VDI with. But you also have some, since on-demand was intended to be a complete system for accessing the supercomputers, you have a way to look at your active jobs. You can compose jobs if you prefer to use a web browser for that instead of just directly doing it. And then there's a system status, which basically just gives you a little bit of information. Well, here I can show you a little bit of information about the cluster. Um, yeah. Let me jump to see what I have next. Yeah, I'm going to talk primarily about the desktop. So I'll just show you these other ones as well. So I can view my active jobs, which is this one here. And when a job is running, you can click this thing here, which gives you a little bit more information about it. And you can also cancel it. So there's that. And there's the job composer, which basically gives you a web interface to setting up. So you sets up your script file. You can edit your script file. So edit files, I can edit my job file, which is just the sort of standard, right? I put my SBatch options here, my command to run. Basically all the sort of things you would just do with the command line if for whatever reason you prefer to use the web interface to do that. And then when you're all ready to go, you can press the submit button to submit it. Or if you need more power here, it tends to put them in directory, so I can open a terminal and edit my files that way. I don't know. I like submitting via the terminal, so maybe I don't fully appreciate the advantage of this interface, but it's there for you to use if you want. All right, so let's talk about the desktop, which is the particular item that I'm particularly interested about. So this launches an interactive desktop on one of the compute nodes. And this gives you access to the resources for the end amount of time. So typically our compute nodes have 4 GB per core, so you might as well request as many cores as you have. So I've got 8 GB here, so I might as well take 2 cores. There's a time limit on these ones here, so 1 to 8 hours, sort of intended for up to a day's work. You can pick your count. And then we have this enable virtual GL, which will allow for hardware OpenGL, which is useful for some applications. So once you have configured this like you want, so I'll just do a short here. We'll just say 2 hours, say. We can launch this. And it's launching. I'll just delete. Sorry, you won't see these ones. It's because I have been using this as prior sessions. So here it was starting, and now it's running already. Let's go forward here. So I'm getting a bit ahead of myself. So yeah, it started already. And the reason is because we submit it to our interactive queue. And so that generally starts pretty quick, because one of the things we didn't want was for people to have to be waiting for something to start, right? Like if you're waiting for something to start, then you're going to eventually get bored and go have lunch or something. And then that's going to be time wasted when it finally starts. And so we try and make it start right away. Now I'm going to talk a bit more about the hardware OpenGL here. Basically, hardware OpenGL runs your OpenGL through the hardware. Most cases are better served with software rendering, but we do have the hardware OpenGL option. It may not work with some applications, but there are some applications with complex scenes where software rendering is slow, and they will benefit from the hardware GL. So the two or the three, I guess, that I've encountered in my past before is possibly ParaView. there is if you're doing VMD and viewing a very complex molecule or protein with lots of fancy rendering options turned on, that can get kind of laggy with the software rendering, so that's useful. And then some of our folks who are doing engineering applications and they're setting up their meshes and stuff, and they have a complex scene for their fluid simulations and so on, they can benefit from the hardware as well. But if you're just doing regular stuff, then you don't want the hardware OpenGL. Now, the hardware OpenGL currently uses a H100 node. So the H100 is the latest and greatest NVIDIA card. Using it for graphics rendering is not ideal. There's a couple of reasons for that. There's only 8 of these cards per node. So currently we have 2 GPU nodes devoted to the interactive queue, which implies we can have at most 16 people doing hardware rendering at a time before they're going to be stuck waiting. And then finally, the H100 is not actually good at graphics. The H100 is a really beefy graphics card, but it was made for doing AI and for doing compute. So in particular, they very limited the number of raster operating units on it, so it's not actually particularly fast at pumping out graphics. So for this reasons, we're enabling the MIG option for starters on the H100, which breaks one H100 into 7 smaller units, basically. So that'll give us 65 ability to run 65 sessions per node. So that should solve any issues with waiting, and that should be coming out soon. And then ultimately, we're going to add some nodes with more appropriate GPU cards to run graphics that don't have this problem of the card not actually being meant to do graphics. Now, the third thing that can happen with Accelerate OpenGL is it tests some of the technicalities. It uses an LD preload called Virtual GL, and what that does is that is a library that's injected into the application. It hooks some of the GL, the X11 and GL function calls that application makes, and it reroutes them so that it does the rendering using the EGL and embedded GL backend. Now, this works with most applications, provided they're using the system libraries, because the virtual GL itself is compiled to use the system libraries. So basically, this means all the standard open source software just works with it, right? Where we run into problem is with applications that package up a whole bunch of their own libraries, in particular, if they start packaging up the GL libraries, then those libraries can have dependencies that are not the same as you would see under virtual GL, and you can get a conflict there. Typically, this occurs in the commercial software. I'll just give you an example here. So my desktop has started, so I can connect to it here. So here is the desktop. I'll open up a terminal. And I'll just start up one of our commercial software. So I'll load the AMS package. And if I try and run the AMS viewer, here's a sort of example of an error you can have. So basically, the faker is unable to get the symbol it needed because AMS provides a bunch of its own special libraries. So in the event that you have to run one of these programs and you still need the accelerated desktop, there is an easy workaround, and that's just to unset your LD preload. So if I look at my LD preload here, LD preload. So this is the libraries that get injected when a program runs. It's got some of these virtual GL ones. So I can disable virtual GL by just unsetting that. You can set any number of variables before you run a program. So I'm just setting that to nothing. And then I'm running AMS viewer. And that will have disabled this injection process, which is failing for this commercial package. And it will come up. But if I do run another package, so say I'll load up actual ParaView here, which is ParaView, of course, being an open source package compiled on our cluster. for our system and our libraries. So it comes up fine. And if I bring up the help menu here and I get some of the details, I scroll down, I can see it's actually using the H100 to perform its rendering, which, as I said, the H100 isn't actually great at rendering, so there's probably limited performance to be gained for that. But when we do have when we do eventually get proper GPU graphics cards and we're directing these desktops to those, we should get some better performance for people who do require some heavy graphics lifting. Now, one of the things I had mentioned about liking about this one here is the clipboard works between my desktop and stuff. So, for example, if I let me see if I get this right here. Say I want this bit of text here. I can copy that to the clipboard, and then I should be able to paste it onto the cluster, or I should be able to, highlight something on the cluster here and then paste it back to one of my desktop windows. So that worked for Tiger VNC on Gray VGI, and the reason was because that was an application. The web browsers limit access to your clipboard, and they do that for security reasons. You don't want a random website you're visiting to read what's going on in your clipboard. There might be important data in there. So one of the nice things about the on-demand VNC viewer is they've set it up so it works with the clipboard. This works with most modern web browsers. So I'm told Chrome, I know Chrome works for sure, and I'm told my colleagues Firefox works. I've got an older version of Firefox that doesn't provide that access. So I'm going to show you the second point, which is there's a second side panel they've provided to work around. So in the event that cutting and pasting is not working, so for example, if I highlight this and I cut it, and you can see I can paste it in there, but if I try and repaste it in here, I'm getting the stuff I highlighted up here. So the clipboard between my native stuff and the cluster is not connected at all. If I had a more modern web browser, they would be. For older browsers, what you can do is there's this clipboard workaround. So you can pull out this panel, and then what you put in here, you can see this is here, and then this lets me highlight it as text in the web browser and copy that, which the web browser will interface with my local unit. And then if I want to copy something back, so say I want to copy this bit of text here back, I can put it in here, and then I can paste it as text into the web browser. And then once it's in there, then it becomes available for pasting in here. So clipboards just work, and if you're unfortunately stuck on an old browser, they do have a workaround. So you just have to use this intermediate clipboard. So that was important for me. I was always frustrated with, you try to copy a job ID or something, and yeah, you couldn't copy it. So you had to type it or open a file and put it in it and then transfer the file down and stuff. Now, people have tried this and they find their desktop fails to start. So what are the most common issues that cause it? One of it might be we just have a known system issue. So if you check our status Alliance cans page, usually we'll post about that. So that's always working. Failing that, the desktop requires being able to write some startup files to your home directory. So if you're over a quote on home, that'll stop the desktop from starting. Or more commonly, people have customized their bash RC or bash profile files to load a bunch of stuff. Particularly bad would be if Anaconda stuff manages to work its way in there. And this provides or makes available a bunch of libraries or programs that are not compatible with our regular stuff, causing the desktop to fail. So if you've customized your bash RC or bash profile and you're finding it doesn't start, maybe comment out those customizations, or original versions of these files are under etc. skel if you want to just totally restore the original ones and see if that fixes it. Failing all that, there is if you click on the session ID here, this is the scripts. This runs as a job. So this is the associated scripts. In particular, the output of the desktop startup is in this file here. So you might be able to find some relevant error messages in there. Or more likely, you submit a problem ticket telling us what the job ID or the session number was, and we will look and find relevant stuff in there. Now, one of the things you might have noticed when I started up the pair view, the first time I started up, it was quite slow. Um, that is because that is coming off our CVMFS file system, which isn't particularly fast. Generally, the second time you start an application, it'll start much faster because the system will have cached the files. So you just have to be patient, unfortunately, the first time. And then finally, the other issue that we have seen people have is currently we have very limited applications. One that's come up in particular is there is no internet browser. Um, and this causes problems with some programs that, for example, like to provide their help via websites and stuff. So we looked into that and we talked to some of our people. And so basically, we don't want to provide it in our national software stack because that pulls in a lot of dependencies, and same with our system images. So we've settled on adding Nix to Nibi, which was available on Graham as well, which will put in a bunch of these applications that way. And then that should allow you to add additional applications as well that you commonly need, whether that's a particular editor you like or basically just whatever sort of standard operating system thing you want. Now, that's not for actually running like heavy duty computation stuff. That's just for adding the desktop software that you would need. So that's currently in the process. I'm working on that. I was hoping to have that working by this demo, but I've been busy with some problem tickets that are taking a lot of time. So that did not happen. Which brings me to the end of the session here. So I was hoping might be able to answer any questions people might have or comments or thoughts. As I said, this is very much driven by what we feel will work well for us and be maintainable, plus what we've seen our users are needing. So feedback is much appreciated and will influence our decisions.